chapter 19. I hope you have seen the information that's been uploaded on OneNote. So the upcoming events is going to be your chapter 19 homework, which is going to be due on August 12th, which is very simple and you can do that, okay? But before that, I have to complete chapter 19 work, so I will do that. I think I have few more students. Let me just get them in. Have them. Wonderful. All right. So again, chapter 13 talks about the central limit theorem. I told you not every single population is a normal. Some of the populations are going to be skewed population, irrespective of the left skewed population, the right skewed population. We are trying to bring it to a normal population. So the central limit theorem says go for a sample of n observation. So if you pick a sample of n observation from the population, your variability shrinks. Instead of one observation, if you pick a sample of n observation, what happens? The variability shrinks. So here we have two types of variable. One is the quantitative variable, the other one is the qualitative variable. So if it is your quantitative variable, so this is again the application of the central limit theorem. So the central limit theorem says one for quantitative, the other one for qualitative. So if it is a quantitative variable, then you will see the variability SD of x bar is equal to the standard deviation of x bar is equal to sigma over square root of n. That's right. So you are introducing the z-score x bar minus mu over sigma over square root of n. That's right. And then we have used this concept in testing of hypothesis as well the confidence limit. So chapter 14, we have seen two components. One is the confidence limits for mu with the formula which is x bar plus or minus the margin of error which is x bar plus or minus z star times sigma over square root of n. That's right. And then we have seen the second component of chapter 14, which is the testing of a hypothesis. So where we have seen the recipe, or you can say the 5-step procedure. So the 5-step procedure is going to be your null versus alternative. Null versus alternative. Then we introduce the z-score. And then we have also seen how to get the p-value. The p-value, there are going to be two things. So here I am saying left tail test, right tail test, and then two tail test, right? So here the left tail test is a mu less than mu sub 0, mu greater than mu sub 0, and then mu not equal to mu sub 0 in those two cases. So that's what we have seen. And then the p-value is going to be, again, three ways to do that, which is the normal CDF, and then it's negative 8 comma my z-score value. If it is a left tail test, LTT, and then normal CDF. It's z-score comma positive 8, my favorite number if it is a right tail test. And then it's going to be 2 times normal CDF, negative 8 comma z-score. If it is a negative z-score, negative z-score, negative z-score, 2 times, remember, because it's going to be your two tail test, so it's going to be 2 times. So it's going to be 2 tilde test. Or you can also use it as 2 times normal CDF. It's going to be Z score, comma 8 for 2 tilde test, where your Z score is positive Z score. Positive Z score. So I don't know what's going to be your Z-score value using the formula x bar minus mu over sigma over square root of n. That's right. And then we have seen if a p-value less than or equal to alpha, reject the null hypothesis. Smaller the p-value, we reject the null hypothesis. And then stronger the p-value, fail to reject the null hypothesis. Fail to reject the null hypothesis. All right. So this is what we have seen in our 5-step procedure. So you're going to have the null versus alternative. And that's going to be step number 1. Step number 2. Step number 3 is p-value. And then you are going to compare. And then finally, the conclusion is going to be written. Write the conclusion based on the claim. Conclusion based on the claim. Based on the claim. So whatever statement that you want to be testing, so that's what is going to be written. All right. So the whole thing we have seen in chapter 14. Chapter 14 comprises into 2 components. One is the confidence limits for mu with the formula x bar plus or minus z star sigma over square root of n, and this z star is the critical value. So z star is the critical value. I hope you remember how to get the critical value for various confidence level. We usually put the C level as a 90%, 95%, or 99%, unless otherwise some number is given. So this number is 1.645 plus or minus 1.96 and plus or minus 2.576, something like that. All right. So these are all the concepts that we have seen in chapter 14 when the variable is quantitative. All right. So this is your chapter 19. And your central limit theorem says for qualitative, where you have exactly 2 attributes, so you have exactly 2 attributes, and the respective probabilities are going to be p and 1 minus p, the complement probability, and we have defined the standard error of p hat is going to be equal to square root of p times 1 minus p over n. So the variability shrinks and the curve is going to be a steeper curve, and we have also introduced p hat minus p. I hope you remember everything because this is what the z-score in chapter 13. So this is your z-score in chapter 13. So now you can see the 2 different procedures, one for quantitative and another one for qualitative, where you are exactly given 2 attributes. All right. So now this is where I'm going to be introducing chapter 19. This is where I'm going to be introducing chapter 19. So again, chapter 19, you are going to be having 2 components. One is the confidence limits for P. Confidence limits for P. Like your confidence interval for mu, we are going to be finding the confidence limits for P, which is the population proportion. So the p hat, the p with the hat on is the number coming from the sample, and that's called as the sample proportion. So now here my goal is to find the confidence limits for p, the population proportion, assuming it is unknown. So again, I am going to use from the population, I can take as many samples as possible, and then if I drop all the samples to my horizontal axis, every single sample is going to give me a different sample proportion, which is the p hat. So now I'm going to have the collection of a p hat. When I drop them all on the horizontal axis, will end up getting a normal curve, which is going to be a steeper curve, and the center is going to be right in the middle, which is going to be the p hat. So p hat plus or minus z star, and then I am going to use my sample proportion to predict the probable limits for the population proportion. So this is going to be the estimate plus or minus the margin of error, plus or minus the margin of error. So what is that? The margin of error is going to be on either side from the center. So in my curve, I'm going to say this is going to be the center, that's going to be my center, the sample proportion, and on either side. So I am going to have, what is the sea level here again? The sea level is going to be either 90% or 95%. So that's what I'm going to be writing it as sea level. So this is going to give me the lower limit and the upper limit. So this is what I'm going to be calling it as the lower limit, and this is going to be the upper limit. So I am looking for 1.96 standard deviations above the center, and that's going to be my upper limit, and 1.96 standard deviations below the center, and that's going to be my lower limit. So what is the margin of error? So the margin of error, if my sea level is going to be 95%, then it's going to be plus 1.96 times square root of p hat 1 minus p hat over n. So 1.96 standard deviations above the center, and then here below the center is going to give me my lower limit, which is 1.96 times p hat 1 minus p hat over n. So that's going to be my two boundaries. So the cutoff point is what I call it as a lower limit, which is going to be 1.96 standard deviations below the center. And then the cutoff point is what I call it as the upper limit, and that's going to be 1.96 standard deviations above the center, as long as my sea level is equal to 95%. So in general, I say the formula as p hat plus or minus z star p hat square root of p hat 1 minus p hat over n. So this is the formula given to me, and that is similar to the formula that we have seen in chapter 14, which is x bar plus or minus z star sigma over square root of n. Okay. So here my formula for the qualitative data is going to be based on the sample proportion, and the sample proportion is coming from the sample of n observation. So the sample is the true representative of my population, and based on the single sample data, I'm going to do the projection for the entire population, and the formula is going to be used as. So again, the same concept. So when you pick a sample of an observation from the population, you can pick as many samples as possible. 95% of the populations will capture the true mean. So 95% of the populations will capture the true population proportion, and only 5% are going to be missing. That's because of the presence of a high and a low outlier observation. So the same concept, because you're going to be taking as many samples as possible, and 95% of the samples will capture the center, only 5% will miss that. That's because of the presence of obviously the low outliers or the presence of a high outliers. So this concept remains the same for both chapter 14 and chapter 19 when we discuss about the confidence limits for mu or the confidence limits for p. Okay. All right. So now this is the formula that you need to remember, which is p hat minus 1.96 times the square root of p hat times 1 minus p hat over n, and the upper cutoff point is going to be with the plus sign. All right. So here, as always, I am going to make the tiny critical value table. What is Z star? So for various C level, if it is a 90 percentage or whether it is a 95 percentage or if it is 99 percentage, I am going to have a table of critical values. So this is going to be my C star value. So with your 90 percentage, you are left with 10 percentage on either side. So when you talk about the middle 90 percentage, you are left with the 10 percentage. The 10 percentage is going to be distributed to both ends. So you are going to talk about the inverse norm. So this is the 90 percentage and this is going to be your 0.025 and this is going to be another 0.025. So you know how to get the number inverse norm 0.025. So that's going to be your negative Z star and inverse norm 0.975 is going to be the positive Z star, or you can say the mirror image. So this number is a plus or minus 1.645. You can plug it in and you can check for yourself. All right. And the same way, the next number is a 95 percentage. So with the 95 percentage, you are, when the C level is a 95 percentage, you are left with a 5 percentage. When you talk about the middle 95 percentage, I hope you remember how to get the Z star value. So negative Z star, positive Z star. So those are the critical values. So this number is going to be 0.025. I think I made a mistake. I will fix it. 0.025. So this is going to be 0.05. Because you are left with the middle 10 percentage, the middle 90 percentage, you are left with uh, the remaining 10 percentage that's going to be given to both ends. All right. So the next one is going to be another diagram where you are going to have 99 percentage. So let me complete the table here, which is going to be plus or minus 1.96, plus or minus 1.96. That's right. Okay. All right. So the last diagram is going to be for 99 percentage. So with the 99 percentage, so you are going to have the middle 99 percentage. You are left with only 1 percentage. So this is going to be given to both ends 0.005 and that's going to give me the negative Z star, the critical value, and this is going to be another 0.005. I'm zooming the picture, okay? So here my C level is in 99 percentage. So when the middle 99 percentage is calculated, you're getting the points, which is going to be the negative Z star and then the positive Z star. Okay, so this is inverse norm. Inverse norm. Second was option number 3, inverse norm 0.005 is going to be equal to negative 2.576 and this number is a positive 2.576 which is the mirror image. All right. So I'm going to complete my table which is plus or minus 2.576. Just in case, in your problem, if they have given the number as a 98 percentage, you know how to get the Z star value? Because when I'm talking about the middle 98 percentage, you are left with the 2 percentage, and that 2 percentage is going to be given to both ends. So it's going to be inverse now 0.01. Just going to be inverse now 0.01. So what is inverse now 0.01? Let me use the technology to get that. So it is second was option number 3, inverse now 0.01. That number is 2.33. So this is going to be plus or minus 2.33. So that way you can get some other number different from 90 percentage, 95 percentage, or 99 percentage is given. You can get using your second box option number 2, area to the left of the Z star, which is 0.01. So inverse now 0.01 is plus or minus 2.33. And you can also get another number. Suppose if it is a 96%, then you are left with the 4%. So inverse norm 0.02. So inverse norm 0.02. That's going to give you the number. So you can move the cursor up, and then you can change 0.1 to 2.2. So it's going to be plus or minus 2.0537, something like that. Okay. So this is how we get the critical value based on the C level of confidence, whether it is 80% or 90%, 95, 99, whatever number given in the problem, you can easily get that. And remember, we always want to maximize the confidence level. We never go below 80%. That doesn't show your level of confidence. We always maximize our confidence level when we want to predict the confidence limits for the population proportion. All right. So this is one piece of information in chapter 19. But in calculating the confidence limits for P, there is another method, and that is also discussed in your PowerPoint slide. Okay. So I'm going to complete that section now. So there is another formula that is given in your PowerPoint slide that's called as the adjusted P. So the adjusted P, so everything is given here. You can just go over. Okay, I just went over real quick, but you can refer to the PowerPoint slide and you can see how the same concept that I explained is given in here. Okay, all right. Yes, so here are the two ways to calculate the confidence interval for P. One is called the P hat based on the sample proportion. And as you know, the P hat is going to be X over N. You know that, okay? So the number of individuals, what is the P hat? P hat is given by X over N, number of individuals possessing some characteristic under study, possessing some attribute or some characteristic under study over what is N? N is going to be the sample size. So I want you to recall chapter 13. Recall chapter 13. When you have qualitative variable with exactly two attributes. So P hat is equal to X over N, which is the number of individuals possessing some particular characteristic under study over the sample size. All right. What is the second method? The second method for finding the confidence limits for P is called the plus 4 method. So the plus 4 method tells you P curl. So this is P curl. This is P hat. This is the P hat. Okay. So you should know the difference between what is the P hat and P curl. If I zoom it, you will see the squiggly line. So the squiggly line is what I call it as the P curl. Okay. So that is another method, another improved estimate of your P, which is otherwise known as plus 4 method. So it is reasonably accurate even for the samples as small as 10. Okay. So what is the formula with the P curl? So this is the formula that we have discussed just now, which is Z star plus or minus P hat, 1 minus P hat over N. So that's called as the standard error. So this is what I call it as the standard error. So the standard error, yes, E is equal to, it is square root of P hat 1 minus P hat over N. So when the standard error, there are a lot of technical terms, but anyway, I'll let you use the formula card. So you can use the formula card for your finals. Okay. I don't know what you're going to give because I'm not proctoring your exam. So in all cases, you have to read the problem and you have to understand. But the quiz will help you. So tomorrow or day after tomorrow, maybe tomorrow I can open if I'm able to complete the material today. All right. So this is what I call it as the standard error. When the standard error is multiplied by the critical value, you get O, which is the margin of error. When the standard error is going to be multiplied by the Z star, the critical value, you get your mode, which is going to be on either side from the center. So this is what I call it as the positive margin of error, and this is what I call it as the negative margin of error, which is going to be on either side from the center. All right, and this is the cutoff point. That cutoff point is what I'm calling it as the lower limit and the upper limit. So the cutoff point is going to be the number 1.96 or 1.645, whatever is the confidence level. So that tells you how many standard deviations it is above the center. All right. All right. So now we will see the other method, which is going to be the plus 4 method, because we are all comfortable with the other limit, which is p hat plus or minus z star square root of p hat 1 minus p hat over n. So that is, we are all good. Okay, so the next one is the plus 4 method. So this is pretty new, and we will see this one. What is the plus 4 method? So the plus 4 method is giving you a new number called the p curl. So the p curl is equal to count of successors plus 2 over count of all observations, which is nothing but your sample size, and you have to add 4 to that. Okay, so pretty much the formula is x plus 2 over n plus 4. What is your p hat formula? P hat is x over n, and that's your sample proportion. Lot of formulas, okay? So the sample proportion is going to be equal to p hat, which is simply x over n. What is p curl? P curl is x plus 2 over n plus 4. So here is the formula. So this is the new formula that's going to be used in order to get the C level confidence limits. Okay, so this is going to be Z star standard error of P curl, which is square root of, or if you want, I can rewrite it as, which is going to be Z star, and then it's going to be Z star P curl 1 minus P curl over n plus 4. How about that? This is what they call it as the margin of error. It's the margin of error. Okay. All right. So with that formula, we will be using, so you will be given the keyword. What is the value of a plus 4 estimate? So you are going to find the C level using the plus 4 method. So you can just go over that for the C level, plus 4 confidence limits. So again, the same thing that I said, inverse now 0.10, which is you're left with the 10 percentage. So inverse now inverse now 0.45. And that number is going to be, so you can use your TI. So inverse now 0.05 is your plus or minus 1.645. So that you can also get it from your Z star table. That's fine. We are going to use the technology. So the next piece of information is how to get the sample size. All right, so let me take a detour here in chapter 15. We have seen, it's coming here. I need to go to the top of the page. Very slowly. am here. All right. So now, topic chapter 15. So in chapter 15, I told you that how the three guys are pulling each other. One is the margin of error with the plus or minus sign, or you will also have the keyword within. These are the keywords. And then you have the C level, and the C level is going to give you the Z star number. And then you have N. N is the sample size. And these three guys, they pull each other, and in all cases, we have sigma is known, the population standard deviation is known. So when they pull each other, and I told you that there is a relationship between these three numbers. As n increases, your sigma over square root of n goes down, the margin of error goes down. As the C level stretches, your margin of error stretches. That means they are all getting affected by each other. So in that case, I told you that the new formula that we are introducing for the sample size is going to be, this is the formula. This is what we have seen in chapter 15. So you need to recall the formula that you already took the test. So, the homework on chapter 15, I guess you should be good. So this is the formula that we used here to find how big the sample should be if the margin of error is given, right? So the same way, now in chapter 19, you are given the second component, which is going to be finding the sample size. So how are we going to find the sample size? So the second one is how to get the sample size. How are we going to get the sample size? All right. So if your p hat is known, if the sample proportion p hat is known, then we will be using the second component. The margin of error is equal to, the margin of error is the second component. So this is what I call it as the margin of error. This is the margin of error. This is the margin of error, right? So the margin of error is z star times square root of p hat 1 minus p hat over n. This is the second component, is what I call it as the margin of error. That's right. But in math, I have studied square root of a over square root of b is square root of a over square root of b. So this is what I have seen on radicals. So in math, I have seen square root of a over b is square root of a over square root of b. So this is the property that we are given on radicals. So that way, it is going to be z star times square root of p hat 1 minus p hat over square root of n is equal to the margin of error. I hope you are all agreeing with me. So now I am going to solve for square root of n. So I'm going to swap these two guys, all right? So square root of n is equal to z star times square root of p hat times 1 minus p hat over margin of error. But I don't want the value for square root of n. I want the value for n. So what I am supposed to do here is squaring on both sides. So this is a tiny algebraic concept that you need to do this mathematical operation. I'm just swapping square root of n and moving the margin of error to the denominator, all right? So I don't want the value for square root of n, so I'm going to be squaring on both sides. So I will get square root of n times square root of n. So this is another formula that I have seen in math. So in math, I have seen square root of n the whole squared is going to be square root of n times square root of n. That's going to be n. All right. So when I square on both sides, so this is going to give me the huge number on the left-hand side is going to be p hat 1 minus p hat over margin of error. Do not forget to square that. That's very important. So I am squaring on both sides. So that way my radical sign is removed and I will be getting, and the sample size is equal to z star p hat times 1 minus t hat over the margin of error, the whole square. So that is similar to the formula that I have learned in chapter 15. For quantitative variable, I have seen n is equal to z star times sigma over margin of error, the whole square. So the same way, I am bringing the formula in chapter 19, and that formula is based on the sample proportion p hat. So in all cases, the sample proportion p hat is going to be used as the estimate. So the formula is a bit complicated. It is c star times square root of p hat 1 minus p hat over the margin of the whole square. Don't forget the square. Well, only then you are getting the value of n, otherwise you are solving for square root of n. But we don't want the value for square root of n. Alright, so again the next one is the deductions. So the deductions. What are the deductions here? So if you are no estimate of p hat is given, no estimate of p hat is given. If you are not given the value of p hat, then you are going to let, or you are going to assume p hat is equal to 0.5 and the complement probability p hat is equal to another 0.5. So if there is no value of p hat is given, so this will work only when the p hat is known. This will help only when p hat is given in the problem, when the sample proportion is given in the problem. If p hat is not given, if you are not given any value of your p hat, no estimate of p hat is given, then you are going to be assuming the p value or the p hat value as 0.5, 0.5, 50-50. So that is the fair number, and we are going to be giving p hat is equal to 0.5 and 0.5 respectively. So if we give 0.5 and 0.5, so now you are calculating with C level is equal to 95 percentage. With C level is equal to 95 percentage, the confidence level is 95 percentage. And if your MOE is given, the margin of error is given, then n is equal to, the sample size is equal to, so you are going to have the number as 1.96 times square root of 0.5 times 0.5, because I told you that we are going to be assuming the p hat value as 0.5, plug it in. Whatever is the margin of error, so plug it in, and this is going to be the formula. So you are going to be writing it as 1.96. What is square root of 5 times square root of 5? It's going to be still 0.5, because square root of n times square root of n is going to be n, right? So it's going to be 0.5. Or you can also use your TI to get that number, which is 0.25. Under the square root sign, it's going to be 0.5 over margin of error, the whole square. This is the formula for n. If it is going to be the 95%, a lot of formulas are coming here. But I had a worksheet and you will be comfortable with everything, because this is the way I'm going to be introducing all boxed formulas, and should be okay. So this is going to be the using your z star value is going to be equal to, I'll just put the lines. So the lines is much better. Okay, so here the z star value is going to be equal to plus or minus 1.96 for C level is equal to 95%. C level is equal to 95%. That's right. So far, we have seen three formulas. One is this formula, which is the confidence limits for P, which is P hat plus or minus Z star, square root of P hat, 1 minus P hat over N. So that is formula 1 for finding the confidence limits for P. The second formula is going to be your plus 4 method. So the plus 4 method is giving you the formula plus 4 method. Plus 4 method is giving you the formula which is P curl plus or minus Z star square root of P curl 1 minus P curl over N plus 4. This is the plus 4 method formula. But what is P curl? Where P curl is equal to the new estimate is x plus 2 over N plus 4. So this is our second formula that we have seen. And the third formula that we have seen is here, which is how to get the sample size. So n is equal to the sample size. N is equal to this. So these are all the three formulas that we have seen, or you can also get this formula. This is the sample size. This is the deduction result. Suppose you are not given the p hat value, then the p hat value is given to be 0.5, or you can assume it as 0.5, and this is going to be in the formula. It is coming from this formula though. So this is only the deduction result. So far we have seen three formulas in chapter 19. Alright, so now I am also going to introduce the testing of hypothesis, because you have already seen the testing of hypothesis in chapter 14. So that way my work will be done. So two formulas for confidence interval, and then one formula for the sample size, and then the next part is going to be the testing of hypothesis. If you have any question, I can take your question. Otherwise, I can go ahead and complete the testing of hypothesis. With that, our material for chapter 19 will be over. So I just give you some time. Just go over the three formulas that I have written. So I can just recall one more time all the formulas. And if you have any question, you can check with me. So I'm just going to box all the formulas. Let me write, and then if you have any question, I will just take your question, okay? So this is going to be P hat, the confidence limits P hat, Z star times square root of P hat, 1 minus P hat over N. So this is one formula, and this will tell you the confidence limits for P. P, the population proportion. All right, and P hat is equal to x over n, which is the number of individuals possessing some particular characteristic over the sample size. And I am going to write what is the Z star. The Z star is going to be the critical value. So that is the critical value for various confidence level, for desired confidence level, for desired confidence level. The second formula for confidence limits for P is your plus 4 method. So again, this is your confidence limits for P. The population proportion based on plus 4 method. Instead of P hat, we will be using P curl plus or minus Z star times square root of P curl, 1 minus P curl, maybe I can write it very clearly, 1 minus P curl over N plus 4. where P curl is equal to the new adjusted number, which is x plus 2 over n plus 4. And Z star is equal to the critical value at the desired confidence level. Critical value at desired confidence level. So this one is the plus 4 method. And the third formula that we have seen is to find n. To find n. N is the sample size, so n is given by Z star square root of p hat 1 minus p hat over margin of error, which is going to have the plus or minus sign, and that's going to be used. This is the formula that's going to be used to find n, the sample size, where n is equal to the sample size. P hat is equal to x over n, which is the sample proportion. So your sample proportion is going to be used in order to find your sample size. What is MOE? MOE is margin of error. The keywords for margin of error is plus or minus or within. All right, so this is going to be the third formula that we have seen. All right, so now I listed all the formulas. You and I cannot change the formula, but if you have any question, you can check with me.
I have a question, Ms. Paula.
Yes, go ahead.
So I was just looking at the worksheet that's right underneath the PowerPoint slides in our chapter 19 folder. And it looks like there were some TI-84 instructions. Do you think you could go over that really quick?
Yes, I will.
Thank you.
But this part, you're okay?
Yeah.
Anybody has any question about the three formulas that we have seen?
I think I'm good.
Okay, how about others? You're all good? As I said, you and I cannot change it because these are all the formulas, and you will be given plus 4 method means in your problem you will be given use the plus 4 method. So you have to use your P-curl formula, right? Otherwise, you are going to go with your normal formula for the loss sample size. So your n is going to be pretty big here. In the first formula, your n will be pretty big. In the second formula, your x will be smaller, say very, very, very tiny number, less than or equal to 10. Or even otherwise, if they have mentioned in your problem, use the plus 4 method, this is what you're going to be using. All right, so coming to your question, the TI part. So again, as I said, for chapter 14, chapter 13, 14, 19, answers are on your TI. So in order to get the interval, you are going to be going to stat, and then you're going to calc, and then you're going to use the test. So this is what you're going to be plugging in. Or sorry, you're going to be using this option. So in this one, I have option 1, 2, 3, and then 4, and then 5, 6, 7, 8, and then 9, and then 0. Yes, I am going to be choosing the option A, which says 1 proportion Z interval. So this is the option that's going to be used in your TI. After 1, 2, 3, 4, 5, 6, 7, 8, 9, then 0, and then you will have the alphabet A. 1 proportion Z interval is going to be used. So once you hit that, you will get the input screen, you will get the output screen. So this is the input screen. Input screen, you are going to be using your option called X, and it will ask what is X, what is X. So that I have shown in my data. So that part is going to be plugging in. You are going to plug how many individuals are going to be possessing some particular characteristic, and then how many individuals are in your sample, and then you are going to choose the confidence intervals. I'm going to go to that screen now. So I hope you're all using your TI. So check for your sum. It's going to be option A, 1 separation C interval. So if I hit that, yes, it is going to ask me what is X, what is N, and then the third number, it will ask you what is the C level. So the desired confidence level given in your problem is going to be entered, and then it calculates. That's it. All right. So what you're going to plug in here is going to be the X value and the N value. So the TI does the math and it will calculate the P hat, which is the sample preparation. So once you have the sample preparation, then TI is going to use that sample preparation in the formula and it will get you the answer. So since I do not have any number, I can show you the output screen. I can show you how the output screen will show you the lower limit and then the upper limit, and then it will tell you the p hat value, which is the sample proportion, and it will also tell you how many samples you have in your data. All right. So this option is going to be used for large sample test as long as you are going to be using p hat plus or minus z star square root of p hat 1 minus p hat over n. Only for this formula, you can use your TI. For plus 4 method, you cannot use your TI. No TI option. No TI 84 option available for plus 4 method. Option available for plus 4 method. So that you have to do it by hand. Do it only by hand. All right. So only for this formula, you can plug in the numbers, boom, you will get the lower limit and the upper limit. But for plus 4 method, you have to do it by hand, the P curl, and then the limits are going to be done using P curl plus or minus Z star square root of P curl 1 minus P curl over N plus 4. So this you have to get the lower limit and the upper limit by hand. All right, so let's see the last piece of the information, which is the testing of hypothesis. Which is the testing of hypothesis. So the testing of hypothesis, as you know, it has a 5-step procedure. So I'm going to recall one by one. So you are going to have x sub 0, p is equal to p sub 0, the number given in the problem, which is the population proportion. Versus the alternative could be one of the three, which is p less than p sub 0. You just recall the chapter 40 testing of hypothesis procedure. Just now I said everything, okay? Or p could be greater than p sub 0, or p not equal to p sub. It's going to be identical to that, all right? So this is my left tail test, this is my right tail test, and this is my two tail test. So the first step, you're going to have the null versus alternative testing of a hypothesis, which involves 5-step procedure. So basically, you are going to be testing the validity of the statement or the claim or the sentence on P. So you are going to look for, proof or evidences to say whether the statement on P is good to go or it's going to be rejected. So we are looking for sufficient evidences to accept the statement on P or reject the statement on P. So that's going to be the goal of testing the hypothesis. All right. So once I define the step number one, null versus alternative, I am going to introduce the z-score, which is not new to you because you have already seen this in chapter 13. So my z-score formula is p hat minus p over square root of p times 1 minus p over n. So you will be given the population proportion. You will be given the statement about the population proportion. All right, only then you can get the z-score. And you will also be given x and n values so that you can get the p hat, where p hat is going to be x over n. Remember that, okay? All right. Let me introduce where p hat is equal to x over n, which is the number of individuals possessing some particular characteristic over the sample size. That's right. And your p value is going to be the number coming from the population, so that's also going to be given. Okay. All right. So null versus alternative, then the z-score or the z-test statistic. And then the step number 3, as you know, immediately I'm going to calculate the p-value. So what is the p-value? If it is a left-tiled test, again, it is a normal CDF, it is a -8, comma, my favorite number, and that's going to be the z-score. And this is going to be for the left-tiled test. Just write it as left-tiled test.